Hi students, welcome to Max Point of View. Today we are going to solve each and every numerical from the chapter Electromagnetic Induction and its application to AC generator and transformers. This is part C of Electromagnetism. Here we are going to solve all the numericals. Before watching this video, watch the concept video as well as theory video first. Then you will understand all the numericals in a easier way. So without wasting any time, we'll start with our first question. Our first question, the magnetic flux through a coil having 100 turns decreases 5 milliweber to 0 in 5 seconds. So here many values are given. First we'll note it down. Okay. Here what are the things given? Number of turns is equal to 100. Then the flux, okay, magnetic flux decreases, right? So magnetic flux symbol is this one, is equal to 5 milliweber. 5 milliweber. Next, to 0, we don't have to care about it. 5 minus 0 is 5 again. Then in 5 seconds, time is given as 5 seconds. So what is the formula? So we have to calculate the EMF induced. So EMF we have to find. So what is the formula? EMF is equal to N into delta flux by delta T. So all those things, see here, whenever they give, so this is the delta. So the delta means change. The triangle we call it as delta. If you see any triangle, that means there is a change in the value. So what is the change they have given? 5 milliweber to 0. Whatever the two values they have given, you have to subtract it. But if you get negative value, don't use the negative value, just subtract it and take the value. Okay, anyhow in this question 5 milliweber to 0. So 5 minus 0, it is 5 only. So that's why we are going with 5 value. Okay, this represents flux. Okay, this symbol represents flux. Delta T means change in time. So we need EMF is equal to N, represents number of turns, 100 into 5 milliweber. So if we write just 5, it is correct, right? 5 milli means what? 10 power minus 3. Okay, divided by time. Delta T is given as 5 seconds. 5 get cancelled, so it is 100 milli. What we are finding? EMF is nothing but voltage. So it is EMF is equal to 100 millivolts. That's it. Our next question, a primary coil of a transformer has 800 turns and secondary coil has 8 turns. It is connected to 200 volts AC supply. What will be the output voltage? So first we'll write the given data. So primary turns, okay, here when it comes to transformers, the symbols, all these things, when it comes to not only transformers, electromagnetism, all these videos, the symbols what we are going to use, those are very much important. So number of turns, okay, the primary turns are 800. So this is the symbol for turn. For primary we'll use NP. NP is equal to 800 and NS is equal to 8 according to the question. And it is connected to 220 volts AC supply. So whatever the connection we make to the transformer, that is always towards primary. So primary connection is 220 volts. So for voltage we use symbol when it comes to, we use the symbol E when it comes to transformers. So voltage at primary is 220 volts. And what will be the output voltage? Voltage at secondary we have to find. So this is based on turns ratio, correct? Turns ratio. Now what is turns ratio? ES by EP is equal to NS by NP is equal to IP by IS. See, there is some change here, correct? So this is nothing but turns ratio. This is what we have completed, understood in the concept video. That is why I always suggest watch the concept video first, then you will understand all these things. Now listen, so here there are three things, voltage, number of turns and current. This question is about what? Number of turns and this one, voltage. So we have to use only these two. Okay, if the question was about voltage and current, we should not use number of turns, we should use ES by EP is equal to IP by IS. That's it. Anyhow, this question is about number of turns and voltage. We are using first two. Okay, so here we'll substitute all the values, we'll find the remaining one. So ES, that is what we have to find. EP, that is 220 is equal to Ns is 8 divided by Np, that is 800. So if you want ES is equal to 8 into 220 divided by 800. The answer will be 2.2 volts. That's it. Our next question, a transformer is designed to give a supply of 8 volt to a ring a house bell from 240 volts. See, whenever they talk about supply, you should not think of that is an input. No, it is a supply to a doorbell. It is a supply to a doorbell from 240 volts. From 240, see that from 240 is the important thing. That is the supply. That is the primary side. Okay, that is from 240 to a house bell of 8 volts. This is what you need to understand. So whenever they talk about give a supply of 8 volts, you should not think that is the primary side. So it is from 240. So input is 240. That is a doorbell. That is what we have learned in concept video. Doorbell, it is step down transformer. Step down means input is more, output is less. These kind of tricks you have to use when it comes to questions like this. So this is third question. So input voltage EP is equal to 240 volts. Then ES is equal to 8 volts. Then the primary coil has 4800 turns. Primary coil has 4000. Primary means NP is equal to 4800. Then how many turns will be in the secondary? NS we have to find. So what is the turns ratio? That is ES by EP is equal to NS by NP is equal to IP by IS. It is not IS by IP. This is very important when it comes to turns ratio. Now here, okay, so we are talking about voltage and number of turns. So this is enough. Don't use current. So here what we need to find, NS we have to find NS here. So if NS we want, send this NP that side, ES into NP by EP, substitute all the values. ES is equal to 8, NP is equal to 4800 divided by EP. EP is equal to 240. Answer will be 160 turns. So okay, NS will be equal to 160. That's it. Our last numerical. The input and output voltages of a transformer are 220 and 44 respectively. Input and output. So input, that is EP voltage is equal to 220 volts. Then ES is equal to 44 volts. Then find the turns ratio. So turns ratio, okay, we need to find. Then we have to find the current in input circuit if the output current IS is equal to 2 volts, then we need to find IP. See, the current in the input circuit we have to find, that is input is nothing but primary, current in primary we have to find. Output current at secondary is given as 2 volts. When it comes to turns ratio, we have to see which two values are given for the same physical quantities. Which physical quantities they are talking about? Current and voltage. They are not talking about the number of turns, so don't worry. Now current is there, voltage is there, correct? In which these two physical quantities, okay, two values are given, voltage value is given, so we have to take that for turns ratio. If current two values are given, then we could have used the current values to find the turns ratio. Now we'll use voltage. So turns ratio is nothing but, here we have to use ES by EP. Correct, ES by EP is equal to NS by NP is equal to IP by IS. All those things to find a particular value. When it comes to turns ratio, we have to use any one of the physical quantities where both the values should be given. So here ES is 44 divided by 220. When you solve it, the answer will be 1 by 5. 1 by 5 is nothing but 1:5. That's it. Second question. Okay, if the voltage, okay, if the current is 2 amperes, this has to be amperes. If the current is 2 amperes at secondary, we have to find the current at primary. Now see, we have to use Es by Ep is equal to Ns by Np is equal to Ip by Is. Correct. This is the main turns ratio formula. So here we are talking about voltage and current. We are not talking about turns ratio, sorry, number of turns removed from the formula. So Es by Ep is equal to Ip by Is. We need to find what? Ip. So send this Is that side. So this will be equal to Is into Es divided by Ep is equal to Ip. Substitute the values. So Ip is equal to Es. What is Es? That is 44. What is Is? That is 2. Divided by what is Ep, that is 220. So this will be 88 divided by 220. Answer will be 0.4 amperes. So Ip will be equal to 0.4 amperes. That's it. So now we have solved all the numericals from the part C of electromagnetism. So I believe you have understood the complete concept of electromagnetism from part A to part C. This chapter is very logical and very important to score very good marks in board exams. So because of the questions coming from the electromagnetism, many students will skip that part in part B. See, whenever they get any question related to electromagnetism for 3 to 4 marks, that will be definitely in part B. So because of this one, you should not get rid of other two easy questions. Whenever you get one question for 3 to 4 marks, the remaining two questions will be easy for you. So if you know the logic, you can get the answer within 1 minute. For any question in electromagnetism, you can get for the complete 3 to 4 marks within 1 minute if you have the complete knowledge, if you have learned all these things. Thank you.